All right, the next type of transformations we're going to talk about are reflections. So we have two major reflections and two major rules. So the reflection across the x-axis means that what you want to do is you want to flip the function across the x-axis. Now, I'm going to use the square root function for this one, just because if I switch a quadratic across the y-axis, it actually really doesn't do anything, right? Because it's symmetric across the y-axis. So for this example, I'm going to use f of x as x to the square root. So here would be my original parent function, f of x. If I wanted to flip my function across the x-axis, I'm going to make it dashed too. Why not? What I would have to do is I'd have to make all of the y values negative, right? And since y looks like f of x, all I'd have to do is put a negative in front of it. Okay, so this function would be represented as negative f of x in function notation. So if I had the function f of x equals the square root of x, to get that reflection across the y-axis, I would say negative the whole thing, which would mean negative square root of x. Okay? A problem that a lot of people have with negative reflections is when we're not just talking about parent functions. Okay, so if I was going to give you the function, if I was going to say f of x equaled 3x plus 2. So if I gave you a linear function and said, I want you to reflect it across the x-axis. Well, my reflection across the x-axis is still negative f of x. So what that means is negative f of x, I need to put a negative in front of the whole thing. So a lot of people forget that what that looks like is this. If I put a negative in front of the whole thing, I have to make sure I distribute that negative to everything that's happening. So this and this would be the difference of equations. This would be the original, and this would be the reflection across the x. Okay, but for right now, let's just stick with some parent functions and go from there. Okay, so a reflection across the y is a little different. I'm not actually changing the y value if I reflect it across the x-axis, right? Because this y value is still this y value over here. And this y value is still this y value. So I don't want to change the whole function. I just want to change the x value. So that's when you have something that looks like this. F of x, negative x in parentheses. Okay, so because this is still my square root function, if I did f of x equals the square root of x, and I said, oh, I want to reflect it across the y-axis, I would say I'm going to put the negative in here and make it this way. Okay, and that's why now those positive numbers don't work, because a negative negative is a positive, right? So when you say, oh, you can't have negative square roots, yeah, you're right. But if I'm looking at this as for like domain, I'm saying negative x is greater than or equal to 0. So I'd have to divide by a negative, which changes my sign. Okay, so it's just like those horizontal shifts. Anything that happens inside parentheses is always opposite really what you want it to be. Okay, so because the square root functions are like this, they are allowed to be negative if it is a reflection. So that's why this function would look like this, f of negative x. Okay, now again, the reason why I didn't use f of x equals x squared here is because if I'm going to reflect it across the y-axis, if I was going to graph this, here's my original parent function. if I was going to reflect it across the y-axis, if I was going to spin it around, it would still look like the parent function. And now we can prove that by doing it algebraically. If I have f of x equals negative x, that still just means I'm plugging in negative x for x squared. And since a negative squared is a positive, I get this function. Okay, so any of your even functions will always have this property where a reflection across the y-axis doesn't really do anything. Because it's already symmetric. Okay, so that's reflections. So now my challenge problem here is going to be this. If I have a cubic reflected across the x-axis, shifted left 2. I'll give you a moment to pause. All right, so if I was going to do this, I would say, well, f of x is equal to x cubed. So if I want to reflect it across the x-axis, I have to use this rule from up here. So I'd have to say negative f of x. And then if I wanted it to be left 2, I'd have to erase this parenthesis here because I'd want it to go left. And again, remember, left actually means how far away am I from 0, so I'd have to add 2 to get back to 0. So this would be my new function. So I'd have to do that in this function. I'd have to say negative x plus 2 cubed. I almost wrote squared there because I'm getting stuck in squared. And I hope that's what you had on your paper.